Welcome to the 7th tutorial of electrical estimation. In the last tutorials, we learned how to do the takeoffs for lighting, power devices, and low voltage devices. In this tutorial, we are going to measure the length of cable trays and conduits. We will move to the second floor and will quickly go through the counts of lighting, power devices, and low voltage devices. One more command that we will learn in this tutorial is how to measure the area of a floor. Lighting and power devices takeoffs on the first floor. There is the lighting takeoff, then power devices takeoff, then security devices takeoff. Okay, now this is the drawing for cable tray. We will measure the length of cable tray and some conduits. So you will be noticing a tag here which is CT-1 and it is tagged by note 1. So let's see what does the note 1 say. Furnish and install cable tray for all low voltage cabling routed to interactive base. Okay, so now we are going to measure the length of this cable tray, but first we need to know what's the width and depth of this cable tray. Let's set the scale first. It is 1 by 8 inches is equal to 1 feet. We can measure the width of this cable tray by taking the dimensions. So it is approximately 2 feet, which is equal to 24 inches. So this cable tray is 24 inches wide. Now we can't find the depth of this cable tray from this drawing. So we will have to find the legend for cable tray. Stop it here and open next drawing in new tab. So symbols for cable tray are on drawing E5.00. Here you will see the symbol CT-1. What does its description says? It says cable tray, basket type, center hung. Its width is 24 inches as we measured on the drawing, and its depth is 6 inches. Here is its manufacturer. There is some other description also which says that include all hanging materials and fittings to provide a complete system, provide grounding to cable tray. So all this information is needed while pricing this cable tray. So now we know the width and depth of this cable tray. So let's move to the plan drawing. We will click on the linear command and give name to this cable tray. It was 24-inch wide, so I write W with 24 inches and 6 inch in depth, so 6-inch D. Next is the name of this cable tray or the tag which is given to this cable tray CT-1. So let's measure its length. Start from here. Now there is a bend, but we will add it to our usual length. Now there is another junction. So here is also a part of it, CT1. Okay, so now we have taken the length of all cable tray. Trying. Let's see what is the total of this length. It is 265 feet and approximately 6 inches. Okay, so now what are these other notes saying? Let's see the note 2. It says furnish and install 4-inch conduits to serve as a low voltage cabling pathway from cable tray to MTR location. Verify exact number of 4-inch required with low voltage contractor prior to bid. So this note is tagged with all these three lines. So all these three lines are 4 inches conduits. Let's measure the length of these conduits. Now measure the length of second conduit. You can right click and select new section, or you can simply press N on your keyboard. So a new section would automatically be started. Okay, so now we have done all the work related to node 2. So we will move to node 3. What does node 3 says? It says 3-inch conduit routed to cable tray CT1 for bar, restaurant, and low voltage cabling. One thing you will notice here that where the architect thinks that the use of conduits will be costly, he uses cable tray, and on locations where cable tray will be costly and only one or two conduits will fulfill the purpose, so the architect uses conduits, not cable tray. Let's move to note 4 and note 5. Note 4 is for 1-inch conduit connecting bathroom speaker cable and cable tray. Note 5 is 2-inch conduit routed to cable tray CT1 for event room low voltage cabling. Let's measure these lengths. Now that we are done with note 4, we will measure the length of note 5 conduit. It was 2-inch conduit. So we are done with cable tray and conduits. What does the note 6 says? It says furnish and install cable tray above data rack with waterfalls down to each vertical management section. So there will be some vertical cable tray also. We will have to add the length of that vertical vertical cable tray to this measured cable tray length. Let's say it is 5 feet. We just draw this line of 5 feet. Now it will be added to the total length of this cable tray. As you can see here, it is 270 feet and a half feet above that. So we are done with cable tray drawing. Now we will move to the next drawing, which is E1.12L. This drawing is for second floor lighting. The first drawing for lighting was E1.1L. You will notice the difference that here it was 1.1, now this is 1.2. So for second floor, they have changed the tag of this drawing. We will count the lighting here. So you are noticing type LF-17 lighting fixtures. These lighting fixtures were also given on first floor drawing. So what we need to do is we need to do is move on the first drawing and take the tagged count from there. You can simply click on this green button and the count will start from 44. It is first on this drawing, but when you will move to the summary of the total counts, it will be added to that tagged count. So let's count all these type LF17 lighting fixtures. So you notice that while counting similar items on different drawings, you don't need to name these items differently. All you need to do is pick that item from previous drawing and start counting. So now we are done with type LF-17 fixtures. There are some LF-22 light fixtures. We also counted the fixtures on previous drawing. You can see here there are some LF-15 fixtures, and you will also notice some lighting controls. So we have already done the count of lighting on previous drawing. We will move to the next drawing and skip this portion here. So next drawing is for second floor power devices. Earlier we did the count of power devices on first floor. Now this is second floor. So you can count power devices. Let's say I count duplex receptacles. I will pick this item from here by clicking on the green light showing on the left side. So in this way we will count all these duplex receptacles and different types of these receptacles. All you need to do is click on that symbol and the counting is automatically being done. So let's skip it here. So one thing that is different from the first floor, here you will see the panel boards for second floor. I will open the first floor power drawing also to show you the difference. So here are the panels for first floor. You will notice the tags of these panel boards as 1B, and on the second floor it is 2B. So they have changed the tags of these panel boards according to the floor level. Second floor has its own keyed notes. Now we will move to the security drawing of second floor. So here are some devices for fire alarm system, telecom system, TV outlets, access points. So let's count these devices. On the previous security drawing, these devices were counted as audio visual devices. You can check here. So these are audio visual devices. If you are not sure what was the name of these devices, you can move to the previous drawing and place your cursor on that drawing. The name of that device will show up. Or what you will do is click on that device, and here the name of that device will automatically be highlighted. Let's say I click on this device. So you can see that the name of access point is highlighted. Let's move to the second floor security drawing. These were audio visual devices for fire alarm system. I will pick this item from here and start counting. So in this way, we will count all these low voltage or security devices. So here is an Lloyd plan for this data closet. The purpose of showing the enlarged plan is that this portion is very small, so devices can't be shown here. So what the architecture does, it cuts that plan from here, it reduces its scale. You will notice the scale has changed. Here it was 1 by 8 inches is equal to 1 feet. Now it has become 1 by 2 inches equal to 1 feet. So he enlarged that area, reduces its scale, and shows different devices here. Let's move to second floor cable tray drawing. Here is the same cable tray used of 24-inch wide and 6-inch depth. It is CT1, so it is the same cable tray as on first floor. So to measure the length of this cable tray, we need to set the scale first. It is 1 by 8 inch equal to 1 feet. So I'm setting the scale. Pick this item from first floor drawing. Start measuring. What you can do here is either measure this T in the length of the total cable tray, or you can count it separately and price it as separate item. So I am adding it to the total cable tray length and going to price it as one cable tray. So we are done with second floor cable tray also. So now it's the end of plan drawings. This is the riser diagram. We will learn about this riser diagram tutorial. Here are some details. This detail is for grounding. All these details are related to the grounding system for this building. Then there is panel board schedule. On drawing 301, they have shown the enlarged plan of kitchen. So where was this plan cut from? Let's check the power drawing of first floor. So here is the kitchen plan on first floor. This plan was cut from here and is shown on drawing E301. So what we will do is count these devices on this enlarged plan. The method is similar to that of first floor and second floor power drawing count. Let's say I count duplex septacles. Duplex septacles with tag G. So in this way, I will count all these duplex septacles. This is GC duplex septacle. So here you will see some other tags as well with these duplex septacles. These tags are for information purposes, like you see REF with this receptacle, it is for it means that this receptacle is for refrigerator. This receptacle is for gas fryer. This one is for freezer. And this connection is for soul system. There is a note 4. We can get more information about this connection from note 4. Refeed existing and soul system from new panel K2. Existing baseware system may be reused where possible. All conductors shall be new. So it says that we are to connect this in soul system to panel K2. We can use existing conduits, but the cable inside that conduit will be new. So in the similar way, we will count all these power devices, low voltage devices, and equipment connections on this drawing. The next drawing is also a detailed drawing. It also shows legends. In the same way, there are some other drawings. We will cover these drawings in tutorial. For this tutorial, we are to measure the area of first floor. We will learn the area command. So I'm going to use the area command. Click here. You can use new area command here. If you are to measure the area of roof, you will click on roof area, as the area of roof is not a plane level area, so you have to add a pitch factor in that area. This is floor area, so we can simply click on new area. Now that I have given a name, I will measure the total area of this floor. So this is outer boundary. What I am going to do is measure the area from inner boundary. I will click from this starting point. You can start from anywhere. Keep clicking on the endpoints. You are to cover all these endpoints by clicking on each point. Stop it here. So you are noticing that all the floor has been highlighted. So what's the total area of this floor? You can check it here. It is 15,462 square feet. You can also place your cursor here. The total area will show up. So that's it from 7th tutorial. In the next tutorial, we will learn more about these drawings. We will try to learn the we will try to learn how to measure the length of circuitry, branch circuitry for power devices, lighting and low voltage devices. So this tutorial ends here. I hope that you are learning well. If you have any questions, you can comment below this video. We will try to answer you in the reply section. But if the answer is of bigger length, we will try to answer that in the next video. So that's it, and thank you.